Okay, this is section 4.4, and we're going to divide this up into two parts. So this is part one. And they're going to give us some new definitions for our trig functions. And so far we know that sine theta is opposite over hypotenuse. Or we also learned that it is our y value. Okay, but let's think about this. If we've been talking about our unit circle, okay, it's going to be kind of an ugly unit circle. But we know on this unit circle, for it to be a unit circle, what does our radius have to be? Well, we already know that this is the point 1, 0, 0, 1, and so on. So the radius of this circle is 1. So does it make sense that sine theta is my y value over my radius? But my radius in my unit circle is just 1. Okay, so this is where that r is coming from. R stands for the radius of this unit circle. And so they're saying let theta be an angle in standard position with xy, a point on the terminal side of theta, and our radius equals, and this is the square root of x squared plus y squared. Okay, I'll show you what that means in a minute. Basically, they're just saying that we can draw our triangle in standard position, and the hypotenuse will be the same thing as our radius. Okay, so we know that sine theta is y, and now they're going to say that that's the same thing as y over r. Cosine we know is our x value, or another way to say it would be x over r. And then tangent hasn't changed anything. We know it's y over x. And then we have our reciprocals over here. Sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. Remember, these are reciprocals. So what they're going to do now is they're going to give us certain information, and we have to come up with our own triangle, and then we have to use Pythagorean theorem to find that third side, and we're going to find the trig values that they're asking for. So it sounds like a lot, but really you're not learning anything new. They're just asking it in a different way. So here's example 1. It says let the point -3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So what they want us to do is they want us to draw our triangle where the terminal side lies on the point -3, 4. So you know what I do? I always just plot that point. So I'm going to plot the point -3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, so here's that point. All right, so from that point, I'm going to draw a triangle. And my triangle will always start, because this is the angle that they're talking about. Okay, if I'm starting here, standard position, here's my angle. Okay, and I'm going to go all the way to -3, 4. This is the terminal side of my angle that I just drew. And from that angle that I drew, I'm going to make a triangle out of it. So now my new triangle, you already see it, is this triangle right here, this right triangle. All right, so if this is my right triangle and I use the point -3, 4, we have to label our sides. So my x value, I had to go to the left -3, so this side is -3. I had to go up 4, so that side is 4. And now I can use Pythagorean theorem to find this third side. This third side happens to be the hypotenuse, or the radius of this circle now. Okay, if I were to draw in my circle, my hypotenuse now, or my radius, is 5. All right, so I have a 3, 4, 5 triangle, and now that's all the information I need to know in order to find sine, cosine, and tangent. Okay, now theta is this angle right here now. All right, so theta will always be inside your triangle. So sine theta, we can think of it as opposite over hypotenuse, or now we can think of it as y value over my r value, and r will always be your hypotenuse. So sine theta is 4 over 5. Cosine theta is my x value over my r value, so -3 over 5. And tangent theta is my y value over my x value, or opposite over adjacent. So 4 over negative 3. And that's it. Now, let's kind of check our answers. Do you remember how we can check the signs of our answers? All students take calculus. Well, let's remember what this means. This means everything, all functions are positive in this first quadrant. In the second quadrant, remember this is first, second, third, fourth. In the second quadrant, the S stands for sine and its reciprocal, which is cosecant. That's the only thing that should be positive in the second quadrant. Okay, in the third quadrant, tangent and its reciprocal are positive. Everything else is negative. And the last one, cosine and its reciprocal are positive. Everything is negative. So we are in the second quadrant over here. So what should be positive? In the second quadrant, sine and cosecant should be positive. Everything else should be negative. So look at our answers. My sine is positive. Cosine and tangent are negative. So that follows that rule. Okay? All right, so let's look at example 2. Given tangent theta is negative 5/4 and cosine theta is greater than 0, find sine theta and secant theta. Okay, well, here's the deal. They didn't tell us where to draw our triangle. We have to figure that out. All right? So let's look. First of all, they told me that tangent, and I know tangent, is y over x. Okay, now here's the deal. And they gave me 5 over 4. So I know that that negative, because there's a negative in front, can either go with the 5 or can't it go with my 4? I have to figure out which one. Okay, so let's first look at this. Tangent is negative. All students take calculus. So the only two quadrants that tangent is negative is this one right here and this one right here. Because everything's positive here, tangent's positive here. So second or fourth quadrant are my choices. That's the only place that tangent is negative. But then they also give me this restriction. Now, out of these two quadrants, which one is cosine positive? Cosine is greater than 0. Greater than 0 means positive. Okay, well, cosine is positive in this quadrant. Okay, it's negative here. So between these two quadrants, I know that cosine is positive in this fourth quadrant. So that's the quadrant I'm going to draw my triangle in. Okay, so I'm going to draw my triangle in this fourth quadrant. Okay, and so that means I'm going to go to the right 5, down 4, and there's my point. Okay, because I'm plotting the point 5 over 4. This is y over x. Whoops, that's the wrong point, isn't it? So y over x. Let me get my marker back up. All right, so my y value, my x value, I'm going to go to the right 4, down 5. And whenever I draw my triangle in, I'm always going to drop it perpendicular to the x-axis. Okay, so here's my right angle, here's theta. Okay, so they're actually, if I drew my initial side, okay, all the way around, this is where this point is. So I went to the right 4, because my x values are 4, and I went down negative 5. Okay, so there's my triangle. If I do the Pythagorean theorem to find this third side, 4 squared plus 25 squared, and then take the square root, that third side is the square root of 41. Okay, so now they want me to find sine theta and secant theta. Well, we know that sine is y over r. So my y value is negative 5, and my r value is the square root of 41. We're not going to rationalize. Secant theta is r over x. R over x. So my r is the square root of 41. My x value is 4. Okay, and we'll do another example like this in your homework. Okay, example 3. Evaluate the sine and cosine functions at the angles 0, pi over 2, and 3 pi over 2. Okay, they just want to make sure you remember what we call our quadrantal angles. Remember quadrantal angles? Okay, on my unit circle, my quadrantal angles are 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Okay, so do you remember what those points are? If I'm on the unit circle, this is the point 1, 0. This is the point 0, 1, negative 1, 0, 0, negative 1. Okay, so they want us to find sine, cosine of these three angles. So the sine of 0. Sine of 0 is y value, so that's 0. Cosine of 0 is my x value at 0, which is 1. Now I'm going to find the sine of pi over 2. Here's pi over 2. Sine is my y value, so it's 1. Cosine of pi over 2 is my x value, which is 0. Now they want us to find sine of 3 pi over 2. 3 pi over 2 is right here. Sine is my y value, so that's negative 1. Cosine of 3 pi over 2, that's my x value, which is 0. Okay, so they're just practicing your quadrantal angles. Example 4. Okay, so those are all the types of problems that we're going to cover, but now let's, just as a reminder, let's do some of your homework problems together. We're going to start off with number 4. And number 4, you have two parts to it. Part A gives you this. They have drawn in your point. Okay, here's your initial side, here's your terminal side, and this is the point 3, 1. Okay, well, we know that after we plot our point, we have to make a triangle. I'm going to drop that side down to my x-axis. Your point will always touch the center. So here's my nice little triangle. So if this is the point 3, 1, that means my x-axis, I went to the right 3, up 1. And now I want to find this missing side. So using Pythagorean Theorem, you should get square root of 10 as your r, or as your hypotenuse. And now they want us to find, let's see, the 6 trig functions, okay, of this angle. So sine of theta equals, sine is y over r, square root of 10. And we're going to leave it just like that. Or you can think of it as opposite over hypotenuse. Cosine theta is x over r, 3 over the square root of 10, or adjacent over hypotenuse. Tangent theta is y over x, 1/3, or opposite over adjacent. Okay, so that's part A. Let's do part B. So part B, they gave me a different point. B is the point 2, negative 4. So basically what they've done is they started off with this initial side. Okay, they went all the way around, and their point's right here. So I'm going to draw my triangle, and then there's theta, and I'm going to label my sides. Okay, if I went to the right 2, down 4, so right 2, down 4, when I use Pythagorean Theorem, that's going to be 4, 16, that should be square root of 20. Now, square root of 20 will actually simplify. This is 4 times 5. 4 is a perfect square, so that actually simplifies to 2 square root of 5. So that part, we are going to simplify that. Oh, and over here, I forgot. I didn't do my other 3. Sine and cosecant are reciprocals. So cosecant is that. Secant is that. And then cotangent is 3. Okay. So let's do our six trig functions. Sine theta. Sine is my y value, and that should be -4 right there. My y value over r, so -4 over 2 square root of 5. My 2 and my 4 can cancel, so I would go ahead and do that. Cosine theta is x over r, so 2 over 2 square root of 5, which is 1 over square root of 5. Tangent theta is y over x, so -4 over 2. Did I write that problem down wrong? 2, -4. Okay, I was just looking at the wrong one. Sorry. All right, so tangent theta is -2. All right, and then let's write down their reciprocals. So cosecant theta is square root of 5 over -2. Secant theta is square root of 5. Cotangent theta, the reciprocal of 2, is 1/2. All right, let's do our next problem from the homework. Number 28 from page 285. 28 gives us this. It gives us this equation of a line, 4x plus 3y equals 0. And then it gives us a quadrant. It says quadrant 4. And here's what the directions say. The terminal side of theta lies on the given line in the specified quadrant. Find the values of the six trig functions of theta by finding a point on the line. So here's the deal. First thing we need to do is we need to kind of graph this and see what it looks like. So in order to graph a line, we need to solve for y first. So I'm going to subtract 4x, and I get 3y equals -4x. So since I'm solving for y, I'm going to divide by 3. So y equals -4x over 3. Now, remember when you're graphing something, or graphing a line, I'm always looking for my y-intercept first. My y-intercept is always the number without the x. Okay, here's my equation of the line. I don't have a y-intercept, or it doesn't tell me one. Okay, so when I don't have a y-intercept, okay, it's going to be 0. So I'm going to start here at 0, and then this is my slope. Do you remember what to do with the slope? Okay, I'm going to go up and over, or down and over. Since this is -4, I'm going to go down 4, 1, 2, 3, 4, and to the right, 3. And then I could do it again, or I could go up 4 to the left 3, up 4 to the left 3. But it told me to graph this line, and really we only care about the part in quadrant 4. That's where the point lies. So I already have that point. So from this point, I can draw my triangle, just like we've been doing. Here's my right angle, here's my theta. Let's go ahead and label this. This is 1, 2, 3, and then I went down 4. So when I use Pythagorean Theorem, this would be a 3, 4, 5 triangle. So now they asked for the six trig functions. Okay, so sine theta. Sine is my y value over r, or opposite over hypotenuse. That's -4/5. Cosine theta is x over r, so 3/5. Tangent theta is y over x, so -4/3. And now I'm going to find the reciprocals. Cosecant, 5 over -4. Secant, 5 over 3. Cotangent, 3 over -4. Okay, and then last one, number 74 from page 285. Okay, number 74, it says find the indicated trig value in the specified quadrant. And here's what they gave us. Tangent theta is -5/4. I'm in quadrant 4. And they want me to find cosecant theta. Okay, so I already know what quadrant, my point's going to lie. So let's graph it. I know I'm going to be in the fourth quadrant over here, so that means I must be going to the right 5. 1, 2, 3, 4. Actually, is it to the right 5 or to the right 4? Remember, tangent is y over x. So my x value is to the right 4, down 5. So to the right 4, down 5. There's my point. I'm going to connect it with the middle, and I'm going to make this right triangle always to my x-axis. So let's label this. Tangent was y, so my y is -5. My x value is 4. So when I do the Pythagorean Theorem, this should be square root of 41. Now this time they don't want all 6 trig functions, they just want cosecant theta. Well, we should know from our notes, cosecant theta is r, okay, over what? Do they want cosecant theta? Yeah. So they want r over y. So my r value is the square root of 41. My y value is -5. And that's my answer. Okay? So we'll probably work some more examples in class, but that is it for now.